Hello, let's solve a problem here. It is found that if a neutron suffers an elastic collinear collision with a deuterium at rest, fractional loss of its energy is PD. Well, for its similar collision with carbon nucleus at rest, fractional loss of energy is PC. Then the values of PD and PC are respectively. So let's start the question. As you can see, it is given that the collision is collinear, that means it lies along a line, right? Because there is no force acting on it, then linear momentum is conserved, right? Because no force is acting on it. Linear momentum is conserved, right? I mean to say F is dp by dt, right? If net external force, if there is no net external force acting on it, then this is zero. That means moment is conserved, right? This is what it is. So for the first case, it is found that a neutron, let us assume that the neutron, this is a straight line, right? This is mass m and this is for neutron. Let us consider it is moving with velocity, initial velocity v0, and the deuterium is uh, just helium which consists of a proton and neutron, right? Then it can be written as 2 times the mass of neutron, which is at rest, right? This is at rest. Now after the collision, let's assume this mass m, which is neutron, moves with velocity v1, and this guy, this deuterium 2m, moves with velocity v2, right? Now what it is, the initial and final momentums are conserved, right? The initial one is m v0 equal to, as the first one in the initial case, the second 2m is at rest, it will not be included, so this will be m v1 plus 2m v2, right? Then m will get cancelled on left and right hand side, then this will be v1 plus 2v2 equal to v0. As you can observe in the question, it is given the collision is elastic, right? So here in elastic collision, E value is 1. E value is coefficient of restitution v2 minus v1 by u1 minus u2, right? Here the things are v2 minus v1 by u1 is v0, right? Sorry, u1 is v0 and u2 is 0. This is equal to, because it's elastic collision, this E value is 1. Fine. Then this implies that v2 minus v1 equal to v0. Fine. As you can see, now you got two equations. As v0 is initial velocity, now you got two equations and two unknowns. You can solve it, right? So now from 1 and 2, right? This is v1 plus 2v2 equal to v0. The second one is minus v1 plus v2 equal to v0, right? Let's solve this. This will get cancelled and you get 3v2 equal to v0. Sorry, 2v0, right? 3v2 equal to 2v0. Then this implies that v2 equal to 2v0 by 3. Fine. So from equation 2, now from equation 2, v1 is v2 minus v0, right? v2 is 2v0 by 3 minus V naught, which is minus V naught by 3. Fine. Finally, we got for the first case V1 equal to minus V naught by 3. V2 is 2 V naught by 3. Fine. Now we need to, as you can see, it was asked that the rest of loss of its energy is PD. So let's figure out the loss of the energy. Now, final kinetic energy of neutron, right, which is half m v1 square. This is equal to half m v1 is minus v naught by 3 whole square, which is 1 by 9 of half m v naught square. Fine. The initial velocity is half m v naught square, right? As the particle initially was moving with velocity v naught. Then loss of kinetic energy is, loss in kinetic energy is half mv square minus 1 by 9 of half m v naught square. We can take this half m v naught square as common. Then this will be 1 minus 1 by 9. This will be 8 by 9. So loss in kinetic energy is 8 by 9 half m v naught square. Then what is fractional loss? Which is given, right? For this fractional loss is this fractional loss half m v naught square 8 by 9 by half m v naught square, right? Which is 8 by 9, which can be written as 0.89. Similarly, we need to solve it for the case of carbon, right? This is given as PD, right? We need to figure out the value of PC now. Similarly, here, as you know that carbon is nucleus is made up of 6 protons and 6 neutrons, then it will be 12 times the mass of the neutron. I mean, to an extent. So at first, only the neutron was moving, which is mv naught, right? Mv naught. Then after a collision, it will be first move with mv1 plus 12 mv2. This is carbon mass, right? Carbon is having 12 times the mass of the neutron, nearly, right? This is m will get cancelled, and this is v1 plus 12v2 equal to v naught, right? And we will apply the same coefficient of restitution formula, which is v2 minus v1 equal to v naught, which is v2 minus v1 equal to v naught, right? I mean, let's solve these questions. Solving equation 3 and equation 4, right, which is v1 plus 12v2 equal to v naught. This is minus v1 plus v2 equal to v naught. Here this will get cancelled, and this will be 13v2 equal to 2v naught. Then v2 equal to 2v naught by 13, right? Then from equation 4, v1 equal to v2 minus v naught, which is v2 is 2v naught by 13 minus v naught. Just 2v naught minus 13v naught by 13, right? Which is minus 11v naught by 13. Fine. Here, now what is the final kinetic energy here for collision with carbon nucleus? Final kinetic energy equal to half m into this v1 is of that neutron, right? Minus 11 v naught by 13 whole square, right? This can be written as in terms of initial kinetic energy is half V naught m V naught square by 11 square is 121, 13 square is 169. Then loss in kinetic energy, right? Loss in kinetic energy is these initial minus final, which is half m V naught square, 1 minus 121 by 69. Let's do this. Half m V naught square, 1 minus 121 by 169, which can be written as half m V naught square into 48, right? So now fractional loss, we need to calculate the fractional loss, right? Fractional loss is this kinetic energy, loss in kinetic energy by the kinetic energy, which is half m V naught square initial kinetic energy. Then this will be, sorry, this is 169, right? Which is 48 by 169, which is given in the answer it as PC, which value is 0.28. So this is the solution. PC is 0.28 and PD is 0.89.